All right, so yeah, two more left. This one here is we're using the intermediate value theorem to show the following equation is satisfied over the given interval. So our equation is that x squared plus x minus 1 is equal to pi over our interval 0 to 2. All right, so maybe recall what the intermediate value theorem is. Recall, if you don't know it like exactly word for word, that's totally fine. You just kind of need the picture. So that's what I'm going to do here. I'm going to draw a picture. Intermediate value theorem says that if we have some value a, b, and we plug those in, and we have f is continuous over a to b, once you plug those values in, let's see here, we get f of b, f of a. If you have this picture, then that means there exists, then by intermediate value theorem, there exists a C in between A and B. I can rewrite that as A is less than C, who is less than B, such that f of C is equal to any value in between f of A and f of B, n, where n is between f of A and f of B. Okay, so that's the picture in mind. It's really it's a very intuitive thing. Right, f is continuous. You pick some number in here, n. Then you can find a value in between a and b, where you plug it into the function and you get that value n. That's what this says, this picture. Okay, so with this in mind, we have a function, f of x is equal to x squared plus x minus 1, who we know is continuous over the entire real line because it's a polynomial. So this is continuous over the entire real line. Now let's plug in values for the 0 and 2, because these are probably going to be our a and b values, and let's see if pi can fit in between there, because if pi can fit in between there, then we can let pi be this n value. And then by the intermediate value theorem, that means this equation is satisfied. Okay, so let's do that. I'm going to come down here. So note f of 0 is 0 plus 0 minus 1, which is negative 1. Also, f of 2 is 2 squared, which is 4, plus 2 minus 1, which is 5. So I'm going to relabel our picture here with our actual values. So our goal is to ensure that this C value exists. But we've just found that A is 0, B is 2. Then when we plug in 0, we get negative 1. Picture is totally not to scale, but that's all right. Negative is usually below the x-axis, but negative 1. And then when we plug in 2, we get 5. So now, since pi since pi, which is roughly 3.14, is in between -1 and 5, by intermediate value theorem, there exists a C in between 0 and 2 such that f of c is equal to pi. And that's back up here, f of c equals pi, which is c squared plus c minus 1 equals pi. And there we go. That's really all you need to do. So your things you need to say that you meet the criterion for the intermediate value theorem. So f is continuous over the interval. And then you need to show that pi is in between some interval inside this interval. It could just be the interval itself, which is what we've done here. Pi is in between f of 0 and f of 2. And that's it. So kind of a maybe harder question just by the nature of it, I guess, or the material, but not hard work, really. You only have to show a couple things that are not super hard to do, right? This is almost given, and then this is kind of easy, and this is easy. Okay.